Okay, in this video, I want to start talking about greatest common divisor. So this is kind of one little subsection that we're going to talk about with primes. So really, everything that I wanted to say about primes, more or less, we've talked about. Um, primes will still be relevant for us, but all the kind of basic facts about primes, I feel pretty comfortable with. So what I want to do is I want to describe the greatest common divisor. And this is an idea that undoubtedly you've seen before. We are going to revisit this just a little bit. This is some nice classic number theory material to talk about, but we'll revisit this. We'll talk about some algorithms, and it turns out that there's some actual good uses for GCDs, including the cryptography use that I kind of hinted at the beginning of the chapter. So cryptography, again, if time allows, we'll go into this a little bit. You won't be tested on cryptography, but there's some material in the book anyways. If nothing else. So what I want to do is I want to describe the greatest common divisor. So given two integers, say a and b, one of them is allowed to be 0, but as long as they're not both 0, then the greatest common divisor will be defined, it'll be unique. Then the greatest common divisor of a and b is literally sometimes mathematicians name things in boring but helpful ways, but it's literally the greatest common divisor of a and b, meaning it's the largest integer that divides both a and b at the same time. Okay, so that's called the greatest common divisor of a and b. I just denote it by GCD of a and b. As an example, if we were to pick, say, 21 and 49, so the GCD of 21 and 49 would be 7. Because if you were to think about all the divisors of 21, so 21 has 1, 3, 7, and 21 as divisors. 49 is 1, 7, and 49 is the divisors. The largest common divisor, in other words, the largest number that's in both lists is 7. Okay, so the GCD of 21 and 49 is 7. So that's all that's happening here. That's all we mean by the greatest common divisor. You could also talk about the least common multiple. This is not quite as useful, and there's good reasons why. But once you know the greatest common divisor, then you can know the least common multiple. So this is the smallest. So this is the smallest positive integer. So this is the smallest positive integer that is a multiple of two integers, say a and d, of a and b. Okay, so we write this as the least common multiple of a and b. So for example, with, if I were to look at the least common multiple of, say, 30 and 12, okay, this would be 60, because you think about all the multiples of 30, you have 30, 60, 90, 120, and then all the multiples of 12 would be 12, 24, 36, 48, 60, 72, and there's going to be common multiples here. So notice that eventually I'll get to 120 again, but certainly the smallest of these will be 60. Now, of course, I have to say positive because 0 is a multiple of any two integers, right? 0 is 30 times 0 and 12 times 0. So it's a multiple of both 30 and 12, but we need a smallest positive integer. So that's the least common multiple.